Greetings, Doctor. We are here to present our project-based learning for the subject KKEE2183 Communication Theory, which is titled FM Radio Broadcasting. Here we showcase our group member, which consists of me, Terence Sue Peow and Edric Sheng, Sue Peow, and Jing Siaw Xin Qing. The problem statement of our PBL is that why FM radio broadcasting is prone to noise interference.
The objective of our project is to determine the various sources of noise, including electromagnetic interference, atmospheric condition, equipment malfunction, human-made sources, and environmental factors. We also evaluate how each source of noise affects FM radio broadcasting, considering factors such as signal distortion, degradation of audio quality, and potential interruption to transmission.
To test the noise in FM radio broadcasting, there are some equipment needed to complete the test, which is FM receiver or signal strength meter, spectrum analyzer, RF antenna, cables and connectors, and lastly, notepad or computer for recording data. For the testing part, we need to identify the test locations and set up the equipment mentioned. And then for the signal strength test, we need to tune the FM receiver to the frequency of the FM station being tested, and we need to measure the signal strength using the receiver. And the most important part is to repeat the measurement because to reduce the error in the measurements, and we need to record the data. For the spectrum analysis part, we need to configure the spectrum analyzer and scan it and focus on the test frequency. And from the test frequency, we need to capture the signal and noise. And we need to measure the noise level to get the signal to noise ratio and record the data. For the data analysis part, we need to analyze the signal strength data, which is to calculate the average signal strength and identify any significant variations. And we need to analyze spectrum data, which is to examine the captured spectrum analyzer traces for any indication of noise or interference. And we need to correlate both with environmental conditions. Lastly is the reporting part, which is to compile all the findings and include visuals.
For every radio, there is a component known as transmitter. A transmitter is a device that exists in a radio, consists of a message signal, modulator, carrier signal, power amplifier, and an antenna. As the name implies, the transmitter sends the information from one end to the other. As you can see, this is the port diagram of a transmitter, which consists of a message signal and carrier signal, which is passed through the modulator for modulation, and the power amplifier for amplification of signal, and it passes through the antenna to be broadcasted to the receiver. For the components of a transmitter, we have a transducer. A transducer is a device that converts energy from one form to another so that the desired characteristic of the input energy can be read at the output signal. The function of the power amplifier is to provide a power boost to the signal. A Class C amplifier is preferred to the transmission. The antenna, which is connected at the end of the radio transmitter, radiates the energy through the communication channel to the receiver. The satellite or dish antenna is a device mainly responsible for receiving or transmitting high-frequency electromagnetic waves from the Earth to the satellite that orbit in free space, and adapting this frequency so that they can be distributed over coaxial cable networks. For the type of modulation, we have AM and FM modulation. The combination of input and high-frequency carrier signal is known as modulation. In the case of AM, which is amplitude modulation. The information is added by varying its amplitude. The message signal and the carrier signal are present at a constant amplitude. Similarly, in the case of FM, which is frequency modulation, the information is added by varying its frequency. The radio signal from the transmitter is transmitted with the help of antenna later on. So this is the transmission of a signal from a transmitter to a satellite. During the transmission, a radio transmitter on the ground station or user device generates RF signals containing data, voice, or video information. These signals are modulated to include the necessary information. The signal then travels through the uplink. The modulated RF signals are directed towards the satellite in space, a process known as the uplink. Once the uplink receives the RF signals, the satellite processes them. This may include amplifying the sound, the signal, and changing its frequency to avoid interference. This is also known as a process called transponding and preparing it for retransmission. The signal then travels down the downlink. The satellite then uses its onboard radio transmitters to send the processed RF signals back to Earth. This downlink transmission can be directed to another ground station, another satellite, or to end user devices. Then the signals travels to the reception. The receiving ground station or user device equipped with a radio receiver captures the downlink RF signals. These signals are then demodulated and decoded to retrieve the original data, voice, or video information.
Okay, now I would like to relate satellite to the receiver. First of all, the content creation is from the uplink receiver, and then it is transmit to the satellite, and then the satellite will transmit the content creation to the downlink receiver. For the concept of satellite transmission, which is use satellite links to transmit the frequency modulation radio content from the central studio to remove the frequency modulation transmitter, which is FM transmitters. So if process starts from content creation from the radio content is produced at the central studio and then followed by the uplink receiver. The content is sent to the satellite via an uplink station. Then the satellite relays the signal. Then followed by the signal is received by the downlink stations, which is antenna located near the FM transmitters. So at the end, the FM transmitters broadcast the received content. Okay, for the flow of receiver, the FM radio content is received by the antenna and then passed to the amplifier to end to the demodulator and then followed by FM filter. Then from the FM filter, it followed by the decoder and then to the signal processing and then at last is the output. Now I would like to explain in detail the flow of receiver. At the beginning, the antenna at the receiver picks up the radio waves carrying the transmitted signal, and then the received signal is usually very weak. Therefore, the signal needs to be amplified to a level where it can be processed effectively using amplifiers. Then, the received signal contains both the information being transmitted and the unwanted signal or noise. Various modulation techniques like amplitude modulation AM, frequency modulation FM, or the phase modulation PM are used, and the demodulator needs to be reverse this process to recover the original signal. And then for the filtering, after the demodulation, the signal may still contain some unwanted noise or interference. Filtering is used to remove these unwanted components, leaving behind the desired information. After the filtering section, the filter and demodulated signal is decoded to retrieve the original message or data. And then, in some case, further signal processing may be required to enhance the quality of the received signal or extract specific information from it, which is in signal processing. And then finally, the processed signal is sent to the output device, which could be a speaker for audio signals or a display for visual data. The information is now ready for use by the intended recipient.
Noise can enter the system of FM radio broadcasting through various means, including electromagnetic interference, atmospheric condition, equipment malfunction, and human-made sources. So the first one, electromagnetic interference can be caused by nearby electronic devices, power line, or other broadcasting equipment operating on similar frequency. Use proper shielding for sensitive equipment. Ensure that adequate distance between broadcasting equipment and potential source of interference, and employ filter to block out unwanted frequency. So for another phenomena, such as atmospheric phenomena such as thunderstorm, solar flare, and temperature inversion, can cause signal distortion and interference. So the solution is implement error correction technique and redundancy in the transmission process. Additionally, diversity transmission path and frequency to minimize the impact of atmospheric condition. So for another one, malfunctioning component within broadcasting equipment or improper setup can introduce noise into the system. So we can do regular maintenance and calibration of broadcasting equipment that can help identify and address malfunctioning component. Proper training for staff involved in equipment operation and maintenance is also crucial. Another one, human activities such as electrical interference from machinery, mobile device, or even intentional signal jamming can introduce noise into the broadcasting system. So we can locate broadcasting equipment away from the source of human-made interference whenever possible. Employ advanced signal processing technique and encryption method to mitigate intentional jamming attempt. For the last one, the environment factor such as geographic terrain, building, and vegetation can obstruct signal propagation and cause multipath interference. So we can conduct true site survey before establishing transmission tower to minimize the impact of environmental factor. We also employ antenna diversity and signal processing algorithm to mitigate multipath interference. In conclusion, FM radio broadcasting is a dynamic process that involves the transmission and reception of radio signal to deliver audio content to listener. While FM radio broadcasting offers numerous benefits, including entertainment, information dissemination, and emergency communication, it also faces challenges such as noise interference from various sources. To ensure the effective operation of FM radio broadcasting system, it's essential to implement robust solutions to mitigate noise and maintain signal integrity. These include measures such as proper shielding, equipment maintenance, error correct technique, and environmental consideration. By addressing these challenges, broadcaster can enhance the reliability and quality of the FM radio transmission, providing listener with a seamless and enjoyable listening experience. Overall, FM radio broadcasting continue to play a significant role in connecting community, disseminating information, and enriching the life of listeners through diverse and engaging content. Through ongoing innovation and adaptation, FM radio broadcaster can continue to meet the evolving needs of their audience while navigating the complexity of the broadcasting landscape.
That's all from us. Thank you.